I thought I'd do an explainer on being wrong.
Interesting. Something, quite frankly, that I would think you're unfamiliar with. Being Neil deGrasse Tyson.
No. So I was once asked.
Yeah.
I give a public talk and
Always.
Q&A at the end.
Right.
And someone said, when was the last time you were wrong?
Interesting.
And I almost didn't understand the question. I had to think hard about what the person meant by that question.
Okay.
And I realized there are levels of being wrong.
Okay,
And I don't think she meant all levels. Okay.
And why not?
Because, for example, all right, I'll be home at 6. And you get home at 6:15. You were
covered in glitter. What happened?
So you were wrong.
Right.
But no, that's not a federal case to be made of that.
No, it isn't.
And you were just wrong. Another one is, let's go left here instead of right. That'll be the fastest way home, and then there's traffic.
Oh, my goodness.
So you were wrong again.
Yes.
All right. So there's all these daily things where you're wrong. And so I'm still trying to figure out what she means by this. Because I'm saying, well, wrong all the time. Wait, where are you coming from?
Everyone is wrong all the time.
Oh, yes.
All right.
Yes. So I started ascending the wrong ladder to find the place where I thought she might have meant. And let me go through scientific wrong, okay? When you are on the frontier, most of the time you're wrong.
Right.
Because there's not enough evidence, or the quality of the evidence doesn't justify being right. All you can say is, this may be the case. I think it's this. And then someone has better data or more data, and they show you that you're wrong.
So this, what you're just pointing out right now, was the biggest mistake with respect to information being given about COVID-19.
Yes, precisely, because people are thinking, well, if a scientist speaks, it must be right.
Right.
Well, when I say E = MC squared, yeah, that's right.
Exactly.
Okay, because we know that's true.
Right.
We have the benefit of decades of theory, experiment, and observation.
So much so that it now becomes a law.
We can call it a law if you want. We stopped calling things law.
Yeah.
We did, just because until the 20th century, it was laws of thermodynamics, laws of gravity, laws of electricity, and then we just stopped that.
Right, yeah.
Because we found that as thorough and as accurate and as brilliant as all those laws were, we realized that they may be incomplete.
Ooh, I love that.
And that's different from being wrong.
Yes.
It's a whole other different thing.
Oh, that's lovely.
Okay, so
incomplete.
It's just incomplete.
Well, the grade I got the most in college.
Incomplete. I forgot about that grade. I forgot about
You forgot that.
Don't give me an F. I'll just.
I am not failing anything. Okay?
I'm just going to be incomplete.
Yes.
INC,
yeah,
period.
INC. I'm just listening. This is going to cost me a few more dollars for these credits. But I'm incomplete.
I forgot all about
taking it again.
The incomplete grade.
Yeah.
All right. So we would find that classical mechanics, as brilliant and as effective and as much as it explained to the world,
right,
it didn't explain the whole world.
Right.
And we needed a deeper understanding. Then quantum physics comes in. We are in the centennial decade of the development of quantum physics as a branch of physics.
That's how young it is?
100 years, yeah. It's the youngest of the major branches of, there are other branches like quantum chromodynamics and things, but basically, in terms of the big-ass branches of physics,
right,
100 years old. Whereas Newton and gravity, been around 400 years.
Yeah.
Okay?
Yeah.
So we find there's a deeper understanding of reality in which it's embedded. So in that sense, you're incomplete but not wrong. Okay?
Excellent.
So I don't know, should one say that you're wrong in that case? I don't know. So because COVID-19 was novel in the sense that it had not come around before.
By the way, that's what they called it at first. The novel
coronavirus. Correct. That's evidence that we were unfamiliar with its ways and means.
Right.
And the ways of how it works, how it gets transmitted, how communicable it is. All of these were uncertain at some level. The CDC, which is accustomed to just declaring what is true, is trying to declare truths about something that is in progress in our understanding of how it behaves. So I think the public and agencies need to look back on that episode and think about how to approach that the next time.
Yeah.
And say, for example, you can say, Here's what we know now based on the research available to us this week. Check back in a week. If there's more research papers that come in, we will update you. Okay? It will say, no, we thought this would work, but we have refined evidence that it'll work better if you add this regimen compared to that regimen. We realizing it's not transmitting on the surfaces as much as we thought.
Right.
You don't have to wash your groceries coming in.
Exactly.
But starting out that way, it might have been the case.
You never know.
You just never know
Right.
when you're on the frontier.
Yeah.
So scientifically, we're wrong all the time on the frontier. But once it gets verified, then by multiple experiments, by multiple people, including your competitors.
Well, most importantly.
Most importantly.
Because
right?
they're the people, like I said, the greatest thing about science is it's filled with haters. Science is filled with haters. And scientists are just like, oh, bring it on, haters. Yeah, check my work. Like, yeah.
There's someone wrote an article, 100 against Einstein.
Right.
Okay. Because they're the haters,
They're
right?
haters.
Okay. Because they didn't want to believe relativity. It was too weird for them. And Einstein replied, I'm paraphrasing here. He says, if I'm wrong, you wouldn't need 100 reasons for it. You would just need one. If you could. Right.
Damn, that's a rap battle if I ever saw one.
That's the quote from Shakespeare. Methinks the lady doth protest too much. Yes.
Yeah.
Here's another way you can be wrong. You can be wrong and right at the same time. All right. So there's Claudius Ptolemy, Alexandrian mathematician, brilliant. And he codified the geocentric universe.
Wow.
Okay?
Okay.
And how do you do that and still make sense of the world? Well, if Earth is in the middle and you look up in the sky and you see planets moving forward and then backwards, slow down and go back forward again, how do you explain that if you're in the middle? The planet must be making loops of its own. Thus was the codification of epicycles, where all planets, as they orbited the Earth, made loop-de-loops of their own. Because that's what we see in the night sky. So he codifies this. He was wrong as all get out.
And it made perfect sense.
But it's what it looked like.
Yeah, look at that. We're seeing it.
And he was humble about it, though.
Really?
In the margin of his book, which exists in the Arabic translation, because I think some of the original copies were burned when the Alexandria Library burned,
Right.
but it had already been translated and was in Baghdad, and it's known today by the Arabic title, Al-Majest.
Al-Majest.
The greatest.
Ooh.
Yes, people knew this was some badass stuff. So in the margin, how humble was he to write, when I trace at my pleasure the windings to and fro of the heavenly bodies, I no longer touch earth with my feet. I stand in the presence of Zeus himself and take my fill of ambrosia.
Wow.
He was feeling it.
He was high as I don't know what.
How'd you get high back then?
Oh,
What did they do?
everybody got high back then. Are you kidding me? And there were no laws against it. That's the great part.
So AD 150 that's what he penned that in the margins of his greatest work, in the manuscript.
That's pretty
of,
cool.
of his greatest work. So there it is. Now you can be wrong, but interestingly wrong. That triggers the work of other people.
Right.
He's on the frontier. So like I said, scientists on the frontier were wrong 90% of the time. He was wrong, but interestingly wrong, because using the epicycles, you could predict where the planets would be.
Exactly.
It had some utility.
Right.
1,400 years later, Copernicus comes along, says maybe the sun is in the middle and not the Earth. If you put the sun in the middle, you don't need the epicycles.
Right.
Because the planets
are doing their thing.
They're all down there.
They're all doing their thing.
Okay.
Right.
Oh, by the way, if you have epicycles, you have to declare that planets occasionally go backwards. They invented a word for that. The astrologers invented a word for that.
Oh, yeah. It's Mercury in retrograde.
Retrograde.
Oh, my God.
That's a little...
Nothing about life is working. Mercury's in retrograde. Oh, my God. Give me my crystal. I need to make sure that my life gets right. Okay, anyway. Listen, go ahead and hate me. I don't care.
What?
Please. Anyway.
You just indicted an entire demographic.
No, here's the thing.
What?
Here's my thing. You are welcome to believe whatever stupid thing you want. You are welcome to believe that. And I should have the right to say, look at you, dummy. That's the problem with the world today.
Okay.
Is that no one can stand up to any type of criticism.
I get it.
You know what I
Okay.
mean? Which is just somebody else is looking at you critically.
All right.
That's all.
Okay. So
Okay.
now here we go. So to have a word for when the thing goes backwards when it's not actually going backwards is an interesting fact.
That is interesting.
And so, for example, if you're at NASCAR and you see the cars going around a circle, when it's on the other side of the track, you don't say it was going backwards.
Backwards, right.
There's not a special word for it when it's on the other side of the sun, coming back left and right. You don't invent words for that.
That's true.
It's
That's
going
true.
in the same
direction,
forward at all times. At all times.
Right.
Okay. So here's what's interesting. Copernicus says, let's put the sun in the middle. Epicycles, even after he did that, were more accurate predicting the positions of the planets than his heliocentric model did.
Look at that.
I know. So, do you throw it out if it's not as good as what was there before? You know why it didn't work?
No.
Because he presumed that the almighty creator of the universe, who
Zeus.
No, we're past Zeus now.
Oh,
Zeus was
right.
Ptolemy.
Okay. Yeah,
now we're talking about he's Christian. Catholic.
Oh, okay.
He's Catholic.
All right.
This
All
is this middle of the 16th century.
Oh, okay.
Okay.
All right.
Polish Catholic.
Right.
All right. So he presumed if God made the universe, what's the most perfect geometric shape?
Circle.
Circle. So planets are clearly moving in perfect circles.
Perfect circle.
Why would God make it work move in any other shape? Exactly.
Because God is perfect.
Exactly. And a circle is perfect.
So it's got to be what
It's
God
got to be
wanted.
okay, exactly.
Yeah, makes sense.
So invoking deity as a motivating force for his scientific thinking. All right. It's not in perfect circles.
No.
That's why he wasn't getting the right answer. It would be another 50 years before Kepler, German mathematician, using data from Tycho Brahe. I practice that. I just want to show off.
Tycho Brahe.
Yeah, most people say Tycho Brahe.
Okay.
Tycho Brahe.
All right.
Okay, I worked that. Just want give me a pat on the back. Right
there
here.
you go.
Thank you.
Sounds like a sausage.
Tycho Brahe.
Tycho Brahe.
Tycho Brahe.
Okay.
A master observer of the night sky.
Okay.
And got data on where all the planets were and everything, and when they were where they were in the sky. Kepler used it, and after tortuously scratching his head over what it all meant, he finally landed on the fact that planets orbit in ellipses rather than in perfect circles. Bada bing, everything
worked out.
Everything worked out. Here's the point. Copernicus was wrong.
Right.
Ptolemy was wrong.
Yes.
Copernicus was wrong.
Yes.
But Ptolemy was more wrong, even though his model made better predictions. So this wrong thing is very weird when you're on the frontier. Just saying.
Within wrong, you can bracket a little bit of right.
Yes. Yes. Beautifully put. And Copernicus bracketed enough right to say, let's stick with this and see if something else needs adjustment. Let's go back 20 years.
All right. Just 20 years.
No.
Or a little more than 20 years.
30 years.
30 years.
Okay. Mid-1990s.
Okay.
There was the discovery of the first exoplanet.
Yeah.
Okay. So now watch. It was a pulsar planet. We're not thinking there's life there.
Right.
Because a pulsar is what's left over after the star blew up. We're not thinking life. But still a planet orbiting another star. This is an important result. And it was a little odd, but this planet orbited once every 365 days. That was a little weird.
Okay.
How do you get that? That's exactly our year.
Of course, yeah.
Other planets in our solar system don't have that orbit. And so these properties that were reported were oddly similar to Earth. The existence of this planet was inferred by its gravitational tugging on the pulsar itself. And pulsars have rapid pulses, so you can time these, you can time it and know exactly if it's coming towards you or moving away. The timings of these pulses are exquisite clocks to check for this. Okay? And they inferred the presence of an Earth-like planet with a 365-day orbit. Headlines.
Earth 2.
Then, 6 months later, somebody looks back at the data. They had modeled Earth as a perfectly circular orbit around the sun.
Oh, that's not
just
good.
to simplify it.
Right.
Sometimes you do that just to simplify the calculations.
Exactly.
But if that's your base model, then when Earth is closer to the sun, we're moving faster.
Exactly.
When we're farther from the sun, we're moving slower.
Right.
That signature got imprinted in the object we were observing. If you don't recognize that that's coming from you, you're going to project it into everything you see. It was egg on their faces.
Of course it is, yeah.
Because they should have known better.
By the way, I understand why that's wrong. So they really crapped the bed.
However, this is science, okay? If you're wrong, you don't want somebody else discovering that.
That's right.
They found it. They printed the retraction, and it was reported at the annual meeting of the American Astronomical Society, the retraction of that paper, and got a standing
And
ovation.
people were like, yo, way to go.
Way to go.
Way to be wrong. You stupid people. You're amazing. Oh, what amazing dummies you are. No.
So the applause was that they found the error.
They found the error.
They admitted the error, and it's not a mark on his reputation.
Exactly.
But if you go to your grave saying, no, I was right, and people already know you're wrong, give up, take on another profession.
Yeah. No, I love that story.
Yes.
Yeah, that's it. That speaks volumes. I love it.
That's science at its best.
Yes.
Really.
Absolutely.
Yeah. When it's at its worst, it's at its best.
Ooh.
Ooh. I need mics to drop.
I'll give you a fist bump.
Oh, fist bump. That'll
There you
work.
go.
So now, that's the frontier of science. Now, am I where this woman was trying to get me to say, when was the last time I was wrong? No, because I figured out finally I figured out what she meant.
What does she mean?
Is there something I believe really strongly with my heels dug in and I'm resisting evidence to the contrary?
Yeah.
Then I'd be wrong and embarrassed by that. She was going a new place that I think pervades in our society. There, people are certain of what they think and will fight you if you think something different. And they can't be, if they are wrong, they can't be convinced of it.
Well, see, that's the thing. Because when you have that belief, which is not scientific, because beliefs, as I have said, I don't believe this. I don't believe in science. I just believe the science.
Yes, it's not something to believe in.
It's not something to believe in.
Yeah. As I said, the good thing about science is true whether or not you believe in it.
Right.
And of course, what I mean by that is the science, not the frontier, because we're all wrong most of the time. It's after that filters in.
Right.
Oh my gosh.
Yeah.
You can't just say, I want to repeal the law of gravity.
Yeah. I don't believe it.
Because you gained 3 pounds last week.
Right. I don't believe it. Right.
Ate too many Big Macs.
Which, by the way, that is the defense, and you'll see people make this defense. I don't believe it.
Right. And so that was the category of belief that I think she was inquiring within me. And I carry no such beliefs that would be susceptible to that question. Because I am always
open to the possibility?
Yes. Because I'm a scientist and evidence matters.
Now, this is what everybody right now who is watching this,
Yes.
this is what they're all asking.
What's that?
So then do you leave open the possibility that there may be a God that
Of course.
created everything?
Of course. All the time.
Oh, snap!
No, that's not a snap
No,
thing.
wait a minute.
No,
We have just really opened up something. No one believes that about you.
Let's assume that there's something in me that we can call belief. Okay? The level of belief I place in something will always be proportional to the evidence that supports it. Imagine your whole life pivots on something that you believe is true.
Oh, I don't have to imagine that. That's already happened.
Okay?
Yeah.
So this might be the case, for example, in religions.
Yeah.
Okay? So Christianity pivots on the resurrection of Jesus. Okay? That's a major feature of Christianity, and belief in that is a major tenet of what it is to be a Christian. Suppose you had access to a time machine, and you say, of all the events in the Earth history, what do you want to witness?
I want to go back to the day where the rock was rolled away.
Exactly. Okay, so
and
let's
they
say...
said, the angel said, he is not here.
Okay, so now you go back to that day.
Uh-huh.
And you see thieves roll it away and steal the body. That would be information that would completely destabilize.
Crush everything.
That's right. So that's the extreme version of what I think she was asking me. When was the last time you were wrong? And she wanted to know how willingly would I give up thinking I was right. So that's an extreme. I give that just as an extreme
got
case.
you. But from a neurological standpoint, it wouldn't make a difference to most people. They would enter a state of cognitive dissonance, and they would find a reason why that information that they see visually does not match with their belief, and then they would find a way to reconcile
cases,
it.
so that they preserve
Exactly.
the belief. I think that's the most extreme example
Yeah.
of what it would be to have a belief challenged. And so if you bring evidence to me
Right.
that is compelling, either better evidence or more evidence, or ideally both.
Okay.
And I'll say, hey, I haven't thought about it that way. Thank you. I will be thankful to the person for calling that to my attention. So that's why I kind of looked like a dog hears a high-pitched sound when she asked that question. I said, what? And then I had to work my way to realize what she meant by it. Because as a scientist, I don't want to say I delight in being wrong. I delight in being corrected.
Ooh.
That's a
big difference.
Yeah.
Yes. Correction always involves advancement and learning.
Yes.
Always.
At all times.
At all times.
Some people are so brilliant that even when they're wrong, they're right.
Okay, now you sound like Scarface. I always tell the truth, even when I lie.
Okay, so Albert Einstein, when he wrote his general theory of relativity, which is the understanding of gravity and the structure of space-time across the universe, it would be applied that way by people like later than that theory.
Right.
He didn't do it all, but he laid the foundations for it.
Okay.
In his equation, there's a mathematical term that if it had a physical reality, it would be an anti-gravity force. And
Are we talking the famous E equals MC squared equation?
No.
Oh,
Okay,
okay, I was going to say.
This is an equation for the universe. And he said, well, all the galaxies in the universe.
That's brilliant. I already see it.
Wait. All
No,
the
but go ahead.
galaxies left to themselves would have the universe collapse onto itself.
Right.
But we're not collapsing.
Right.
So this term would be this pressure force pushing against everything, keeping it in balance. But we don't know anything that's doing that. And so he puts it in there because he has no other way to understand a universe that would not collapse
doesn't
on itself.
collapse.
Okay, he has no way to understand it. So he leaves it in. It's called the cosmological constant. And many, many decades later, by the way, when I'm in graduate school, when we calculate cosmology, we have to put in the constant and say it equals 0. You have to do that because it belongs in the equation, okay? When Hubble discovered that the universe was expanding, then it's no longer a static universe, and he doesn't need the pressure to hold it up against collapsing.
You don't.
And then he said, then he discarded it as this non-physical thing that the math gave him, but it has no physical counterpart, and he called it his greatest blunder of his life.
Oh my goodness.
Until we discovered this negative gravity pressure in the universe, then it's called dark energy.
Exactly.
A Nobel Prize has been given for it.
Yeah.
A Nobel Prize was given for what he rejected. And so Einstein's biggest blunder was saying that was his biggest blunder.
Exactly. Yeah. That's amazing.
Yeah. So anyhow, he was wrong, but right.
God, that guy was just so smart.
Yeah. Anyhow, we're done here.
All right.
Thanks for joining us on an explainer on being wrong.
There you go. Go home, fellas. Tell your wife. You're right, baby.
That's not what I said. That's not the lesson. That's not the takeaway here. All right. Till next time. Thanks, Chuck.
Always a pleasure.
Neil deGrasse Tyson. Keep looking up.